Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything I want to, science and math. And we're talking about physics and current electricity. And I just made a video where my dryer started squeaking in it, and it's probably drove you crazy. So notice how nice it is without the dryer squeaking in this video. All right, so this is explaining how electricity is made. Remember I told you you got to move magnets, and that generates the electricity near the wires. This is a little sketch of what a circuit is like. So how you draw electrical diagrams, a line represents a wire. That is a voltage source like a battery. I is current. You could have a meter on it, like a multimeter if you have one of those. And the load, whatever you're running, is sometimes drawn as a light bulb when it could be anything. And that makes the resistance. So if we close our switch, then the electricity would take off and it would hit resistance as it went through the light bulb. And then some of it would get changed into light. You can measure the current as it's going by, or the voltage. Voltage is a potential electrical energy difference. You can think of current as the flow and voltage as the differences in levels that causes the flow. Okay, and I know some of that's sort of hard to get your head around, but the more you do it, the more it'll make sense. Charge is Q, and it's in coulombs. Power is P, it's measured in watts. The rate of flow of electrical charge is the current, and it is I in amperes. So you've heard of amps, amperes, okay? 1 coulomb per second is an ampere. So here's our first problem, electrical power. It says a 6-volt battery, so voltage is 6 volts, delivers a 0.5 amp current, so current is 0.5 amps, to an electric motor that is connected across its terminals. What is the power that is consumed by the motor? So power equals voltage times current, and we also have this other formula for power, P equals E over T. And that's going to bring time into it so that we can know that. With the, remember, power is the rate of work, and that's in watts. So solutions first, we're going to use P equals VI. So we're going to multiply the volts times the amps, and we get the answer is 3 joule seconds, which is the same thing as 3 watts. Now we want to figure out the E, the energy. So we put it in this formula, 3 equals E over T. And they said if you did it for 5 minutes, well, we changed that to seconds because this is in coulombs per second, and we need our seconds to cancel out so that it is in joules. So we do times 300 on both sides to get it out of the denominator, and 300 times 3 is 900 joules. 900 joules. Da-da-da-da. We got it right. So that's a little lab you could do with a battery and a miniature flashlight battery. Okay. This is something that you sometimes see. It's called a potentiometer. It can regulate current, and you move these around. It's sort of like a dial how it works. Those move around, the ones I've seen. All right, so here's our next problem. Current flow through a resistor. So we want to know how much resistance is going to be in this light bulb. A 30-volt battery maintains a current through a 10 ohm resistor. What is the current? So our formula equals resistance equals V over I. So 30 divided by 10 is 3 amps. All right, that was pretty easy. Here are schematics. Remember I told you a line means like a wire, a conductor. That's the symbol for a switch. That's a fuse. Fuses are made to fail if too many amps are going through there, because that'll cause a fire. A capacitor is drawn like that. You can read more about a capacitor. A resistor is drawn as a squiggly line, and if the resistance can vary, then it's drawn like that, with a little line on it showing that you can change it. And that would be like your switches where you can turn the switch to dim the lights. Okay, so here is some little bits of safety. You want to never put in batteries backwards. You always have to put them in the right way. They'll get hot and can blow up. You never want to throw batteries in a fire. Then you have hot blowing up acid. That's a bad idea. And you never want to mix electricity and water. And in particular, my sister had a friend who had a baby a toddler pull the hairdryer into the tub. Even if the hairdryer is off, it will electrocute the person because what acts as the switch at that point is the water, and it closes the switch. So never have anything electrical near water where you can get shocked. There was a thing that happened a few years ago where a pastor had a microphone at a baptismal pool, and he was electrocuted and killed in front of his congregation. You don't want to mix electricity and water. Okay? So see, this is what I said had to use specific of equipment. So don't do that. Just do the pocket labs or find some more labs on YouTube. Here where you can talk about welding is also a good job. And we have near here, our local college has a welding program. But it's got some health concerns. You can get burned and you can mess your eyes up. But it's still a pretty good job. A heater, so example problem number 3, a heater has a resistance of 10 ohms. It operates at 120 volts. What is the current? So resistance equals volts over current. 10 equals 120 over I. So I is 12 amps. Okay, next part. What thermal energy in joules is supplied by a heater in 10 seconds? So here's our formula. E equals I squared RT. So I is 12 squared, resistance is 10, and time is 10. And we can get 14,400 joules. Those were our givens. So these are pretty easy problems. We would do these in my regular physics. There wasn't even honors back in the day. Example problem 4. The cost of operating an electric device. A modern color television set draws 2 amps when operated on 120 volts. How much power does the set use? So we've got this 2 amps, 120 volts, we want to know the power. Power equals P equals IV, so we just multiply them, and it's 240 watts. So that was our first part of the question. If the set is operated for an average of 7 hours a day, they are watching way too much TV. What energy in kilowatt hours does it consume per month in 30 days? Okay, so now our 30 days, we changed that to if there's 7 hours a day times 30 days is 210 hours. P equals E over T, which is 240 equals E over 210. Multiply both sides by 210. You get 50,400. And then multiply that times 10 cents, and it equals $5.50. So I guess, well, worth all that TV watching, right? And I think that's it for the chapter. It is. All right, that was pretty fun. Come back next time, and we'll talk about series and parallel circuits. And we will get to do some more fun math. All right, you'll have 2 videos because it'll have math also. Like, share, subscribe, and remember, science is great.